Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we'll graph circles. So let's say I want to graph something like this: x squared plus y squared is equal to 1. So I could, if I wanted to, square root both sides. So I'd get the square root of x squared plus y squared is equal to the square root of 1, which is 1. Now I wrote it like this in blue because I wanted to jog your memory. This should bring back memories of Pythagoras. So x is like the distance, how far we go across. Y is the distance, how far we go up from the origin here. So I want the distance to be 1. I want to be able to go across a little bit and up a little bit, and I want that distance there to be 1. So I want to be able to start at the origin, go across a little bit and up or down a little bit, and I want this distance here to be 1. So this graph, x squared plus y squared equals 1, it will be the set of all points whose distance from the origin is 1. So let's just rub these out. Hopefully you realize that when we're talking about a set of points fixed distance from something, we're talking circles. That's the definition of a circle. We start with a center point, and it's the set of all points that are a certain distance from it. That distance is, of course, the radius. So what am I saying here? I'm just explaining why the graph x squared plus y squared equals 1 is the set of all points whose distance from the origin is 1, and it will be a circle whose radius is 1. So it'll go across 1 in every direction. Of course, this will be the coordinate -1, and then it'll also go up 1 and down 1. So the graph will simply look like this: a circle with center, origin, and radius 1. So this is actually pretty easy. So let's look if we wanted to change this graph slightly. To graph what is in black, it's actually very similar to the graph in red. I still have something squared plus something squared equals 1, and those somethings involve x's and y. So this will still be a circle with radius 1. But what we've done is just made a couple of changes, and it turns out they're just simple translations. So hopefully you remember when we were doing things like parabolas, if I replace x with x minus something, this just shifts it left or right. So it always goes the opposite way that you'd expect. This actually shifts our graph. Well, you'd think negative would go to the left, but it actually goes to the right by 2 units. So it's the same idea if I replace y with y minus something. It sort of now goes the opposite way that you'd expect. You'd expect adding 1 would go up. So because it goes the opposite way that you'd expect, this is actually going to go down. And because it's plus 1, it's going to go down by 1 unit. So this is actually going to be a circle with radius 1, but it's just been shifted right 2 units and down 1 unit. So what do I mean by it's shifted right and down? Think of it as shifting the center of the circle. So the center of the circle was originally here at 0, 0. So we're going to shift it right 2 units. So over here is 2, and we're going to go down 1. The center has now been moved here. This is the center of the circle. But the radius is still 1. Because once again, if I, square root this and square root the radius, the square root of 1 is 1. So I start here at this center and draw a circle of radius 1. So once again, I want to go 1 in every direction. So it's going to go up to here. It's going to go across 1. So at this point 3, it's going to go across here. And it's going to go down 1 as well here to -2. So now we've got the basic idea. We've got sort of the points for the circle. We just draw a circle. And there we have it. How easy is that? So let's just look at a couple more quick examples. So I'm going to get rid of this. Please pause and copy down if you need. So what we've sort of discovered, what I was trying to explain to you is that if you want to graph something of this form, x minus a squared plus y minus b squared equals r squared, the graph will be a circle. So these two numbers here, a and b, will give you the coordinates of the center, and you just square root this to get the radius. So let's look at some quick examples. Let's look at x squared plus y squared equals 16. All we have to do is figure out the center and the radius. So there's no a or b, so then you can assume that there's 0. This will have a center of 0, 0, and its radius will be square root of 16, which is 4. So this is a circle. It's the set of all points whose distance from the origin is 4. So we can go across to 4 in each direction this time. So of course what this actually means is that you cannot have any points on the circle where either the x coordinate or the y coordinate is more than 4. Because of course that would mean the distance from the origin is more than 4. So we just mark these intercepts and we'll draw a circle. So we just join it into a circle. How easy is that? Let's look at one more example where the center is not the origin. So let's say we want to graph this one. X plus 4 all squared plus y minus 3 all squared is equal to 9. So we'll find first the center. So this number tells you the x coordinate of it. It's the negative of what's in the brackets, so that's positive 4. So negative 4 will be the x coordinate of the center, and 3, positive 3, is the y coordinate of the center. Because here a is minus 4, because this is x minus minus 4. And b is positive 3. So the radius is really easy. We just square root 9 and we get 3. So let's go and mark these points on the Cartesian plane. So that point I've marked in blue is minus 4, 3. So the radius is 3. So it's going to go up 3 this way. It's going to go 3 this way. It's going to go 3 the other way. And it's also going to go 3 down. So we've sort of marked out where it's going to go. We now simply draw a circle. And there is our circle in blue. So now we're just going to do a few questions involving finding points of intersection. So what we have here, we have two equations of circles in blue, and we're going to find where each of them would intersect with the line y equals x. So we're not actually going to graph these, even though it would be easy. The reason is because apart from, ruling up Cartesian planes takes time, we can't necessarily read off the point of intersection. It might even be an irrational number. Well, it actually turns out that it will be. So what we do to find the point of intersection is we simply substitute one equation into the other. This is just like simultaneous equations, except one of the equations is non-linear. If you graph it, it wouldn't be a line. So we know this equation here, this is a circle with center 0, 0, origin, that has radius 5. So I'm going to substitute the line y equals x into that. So I'm just going to replace y with x in this equation. So I take my equation as normal, and I'm going to rub out y. Everywhere I see a y, I'm going to write x instead. So I get x squared plus x squared equals 25. 2x squared is equal to 25. So what I do is I divide by 2 and then square root. You have to divide by 2 first because we have to undo things in the opposite order to BODMAS. So if I square root 12.5, hopefully you see now there's a positive and a negative answer. You can put it on your calculator and you get 3.53, but the answer is actually positive or negative 3.53. So these will actually intersect twice. One at 3.53 is the x coordinate, and the y coordinate's the same because y equals x. And the second one will be negative 3.53 and negative 3.53 for y as well because y equals x. So, you just have your Cartesian plane, you have your circle with center, origin, radius 5, and the line y equals x goes through the origin like that. So this point here is that one there, and this point here is that one there. That's what it would look like if we did graph it. So let's look at the second one. We're going to do the same thing. We're going to take our equation here and replace y with x. So, no easy way to do it. What we're going to do is we're going to expand each bracket. So hopefully you're really good at binomial expansions at the moment. And then what we're going to have to do is collect like terms. And hopefully you know from here the way to solve it is to get one side equal to 0 and solve the quadratic. So we get 2x squared plus 2x. 5 minus 36 gives you minus 31. So for something like this, the easiest way to solve would be to use the good old quadratic formula. So x is equal to minus b plus or minus the square root of the discriminant. So that is 2 squared, 4, minus 4 by 2 by minus 31, all divided by 2 times a. So the answer we get minus 2 plus or minus the square root of 252 over 4. So if I do minus 2 plus the square root of 252 over 4, I get the x coordinate is around about 3.47, and of course the y coordinate's the same because y equals x, and then minus 2 minus the square root of 252 over 4, I get about minus 4.47, and again the y coordinate will be the same. So they will be the 2 points of intersection. Ever asked to find the point or points of intersection between two curves, lines, whatever, just substitute one equation into the other as we've done here. All right, thank you so much for watching. This has been the luckiest maths teacher in the world. Have a great day.